Hi guys, welcome to this page of the notes. What we're doing is we're working on sequences of transformations. I got a couple more example problems for us, so let's just jump right into them. Here we go. I've given you the image of a triangle, ABC. There it is right there. I want you to find the image, right, of that triangle given the following combination of transformations. So here we go. I want you to rotate that triangle 180 degrees around point P. This guy right here, that is point P right there. There's point P. So we're going to rotate 180 degrees around that point. So we'll go ahead and take care of that. Then I want you to translate it along V. There's my vector V. And then I want you to do a reflection over line L. There is line L. There's vector V right there. So let's go ahead and jump right into this. Here we go. First, the rotation, right? We got to do a rotation of 180 degrees. Now, if you guys think back to chapter 2, section 3. So 2-3, we talked about rotations. We talked about 4 common angles of rotation, right? 90, 180, 270, and 360 degrees. Here's one of those common ones. So if you don't remember what it was, just go back chapter 2, section 3 notes. I put in a table those common rotational transformations, right? And sort of the way that we do that rotation. I gave you sort of the general formula for performing that rotation. So see if this looks familiar. If it doesn't, you can just go back chapter 2, section 3 to find it. A 180 degree rotation is given by x comma y. We're going to perform, the transformation is done by making the x and the y values negative. That's it. By making both the x and the y values negative, you will rotate that image 180 degrees around the origin, right? So hopefully you remember that from chapter 2, section 3. Again, all the stuff we go over in previous sections, a lot of it'll follow into the next chapter, right? Geometry definitely kind of builds on itself, so everything we've already covered you do need to remember and be able to use in later chapters, and this idea of doing a rotation is no different. So here we go. Let's just jump right into this. Call that one right there. That'll be my point A, B, and C. All right, here we go. Point A is at, let's see, it's going to be at -1, 0. So -1, 0. And I'm going to perform my well, actually, we'll do it in a second. Let me get the rest of them. Here's B. Oh, sorry. All right. B is at -1, -3. So -1, -3. That's B. Right there, -1, -3, and C is at +1, -2. All right, let's go ahead and do our transformation. I'll do it in green, why not? Okay, so we're going to do our transformation. Again, the transformation, right, the map for the transformation says make the x values negative, make the y values negative. They don't switch places, they stay where they are, they just become negative. Well, that's easy to do. So A prime, which was a -1, is now a +1, and 0 just stays 0, right? You can't make 0 negative or positive. It's 0. It doesn't have a sign. So that'll just stay a 0. B, switch the signs. It was a -1, so now it'll be a +1. Was a -3, so now it'll be a +3. So that's going to be my B prime. C prime, +1, so now it'll be a -1. Was it a -2, so now it'll be at a +2, and let's go ahead and graph our 180 degree rotation. So 1, 0 right there, that's going to be A prime. 1, 3 right there, that's B prime. C is going to be at -1 right there is C prime. So C prime, B prime, A prime, and there's my triangle after check 180 degree rotation around the point P. But we're not done. Now they want me to translate that triangle, they want me to translate it along vector V. Well, let's find the coordinates, right? So my run is going to be positive 1, 2, 3, 4, 5, right? Yeah, positive 5, and it looks like it's up 1. So I'm going to take every single one of those points, A prime, B prime, and C prime. I'm going to go to the right 5 and up 1. We can do this one in black. 1, 2, 3, 4, 5, up 1. So this is now going to be careful. A double prime. Let's see, B up 1. Let's go right 5, then up 1. 1, 2, 3, 4, 5, up 1. That'll be B double prime. And then C. 5, up 1. Perfect. C double prime. There is the triangle after that translation, right? Based on that vector. So, check. And now we'll do yellow. My final color here, I got a yellow. We need to do a reflection. We need to do a reflection over the line L. Now, please recall back to chapter 2, section 2. We talked about reflections. We talked about 4 common lines of reflection. The x-axis, the y-axis, the identity function, y equals x, and the inverse of the identity function, y equals negative x. Is my line of reflection one of those 4 common lines of reflection? It sure is. My line of reflection is the x-axis. So, if you recall back to chapter 2, section 3, the transformation for reflecting across the x-axis was to leave the x value the same and make the y negative. So, x stays the same, but the y becomes negative, right? So here we go. Let's go ahead and do that. So right now the x stays the same, right? So A is at 1, 2, 3, 4, 5, 6. That stays the same. Then A double prime is at a positive 1. But I need to make the y negative. So I'll go to 6. A triple prime, instead of being at a positive 1, will be at a negative 1. Just make the y value negative. So, right there. That'll be A triple prime. Okay, same thing for B, right? B is going to be over at x equals 6. That stays the same. Then B is at 1, 2, 3, 4. Positive 4 on the y-axis. Make it negative. So 1, 2, 3, right there is B triple prime, right? It's a positive 6 and now negative 4, right? Because you just make the y value negative. Same thing for C. Here we go. C is going to be over at 1, 2, 3, 4. That stays the same. The x doesn't change. Go to the 4. Count up. 1, 2, 3. Positive 3. Make the y value negative. Minus 3. 1, 2, 3. That'll be C triple prime. And there we go. There's my triangle after doing 3 transformations. What we did is we first started with a 180-degree rotation, right? Thanks to chapter 2, section 3. Hopefully you remember all those 4 common angles of rotation. Then I did a translation along the vector that I gave you. And then the third one, right? We went ahead and did a reflection across the x-axis, which takes us back to chapter 2, section 2, where we learned about those 4 common lines of reflection. All right? So again, we're just applying transformations in a sequence, right? Let's keep going. Here we go. Let's see, what do we got here? I want you to do reflection over line L, then a 90... Okay, so we're only going to do transformations here. Hopefully this one will be a little bit easier. Reflection across line L. That is not one of my 4 common ones. So what we're going to have to do, right? Perpendicular lines. We can do that. Here we go. There's A, B, C. All right. Perpendicular line, and then draw the image, the mirror image on the other side of the line of reflection. My point C is 1 unit from the line of reflection. So C prime will be 1 unit on the other side. B is 1, 2, 3 units from the line of reflection, so it'll be 3 units on the other side. 1, 2, 3, right there. B prime. A prime, 1 unit from the line of reflection, so its mirror image will be 1 unit on the other side. Sorry, I should have done this in a different color. I apologize. All right. There. That's C prime, B prime, A prime. There is my mirror image, so that takes care of the reflection. Now I need to do a 90-degree rotation. Do you guys remember? Right? This goes back to, again, chapter 2, section 3, rotations. We learned this transformation for doing a 90-degree rotation. Do you remember what it is? What you do? Switch the x and the y values and make the y negative. Minus y, comma x, right? That's how you do a 90-degree rotation. Again, we looked at that back in chapter 2, section 3. Switch the x and the y values and make the y negative. So let's go ahead and do that to this triangle, right? Not this one. We've already done the reflection. Now we need to rotate this guy 90 degrees. So here we go. A prime is at 1, 1, 5. B prime is at, nope, hold up, I'm so sorry, scratch that. I apologize. Did you see what I did? I accidentally counted from the line of reflection. Crazy me. Origin, count from the origin. Okay, so from the origin, A is at 1, 2, 3, and then 1, 2, 3, 4, 5. So 3, 5. Let's do 3, 5. That's better. B prime is at 1, 2, 3, 4, 5, 6. Whoa, hold up. I'm having trouble counting. 1, 2, 3, 4. How about 5, 2? Let's go 5, 2. And then C prime is at 3, 2. Now, perform that transformation. Here we go. Switch the x and the y values. Make the y negative. So it'll be a minus 5, 3. It'll be a minus 2, 5. It'll be a minus 2, 3. Right? That's all you have to do. Switch the x and the y values, make the y negative, right? So they switch, and then the y becomes negative. They switch, the y becomes negative. Switch, the y becomes negative. Plot those points, right? Keep in mind, this is now A double prime, B double prime, C double prime. Here we go. 1, 2, 3, 4, 5. 1, 2, 3. There is A double prime. Minus 2. 1, 2. There is B double prime. C. 1, 2. 1, 2, 3. C double prime. Awesome. There's this triangle, right? The one in green. The prime triangle, right? Rotated 90 degrees, right? That takes care of those transformations. All right. Hey guys, really good job here. Again, what we're doing is just doing a sequence of transformations, one transformation after another. Now, here's what I want to point out. So far, right, in all of the example problems we've done translations, rotations, and reflections. All of those are rigid. Rigid motions. Do you remember what rigid motions do? Rigid motions preserve size and shape. Go back and look. We've done 3 example problems, and in every single one of those example problems, the shape and the size of the pre-image after doing my sequence of transformations is exactly the same when I get done. I do not change the shape or the size of the figure when I do rigid motions. And so far, that's what we've seen, sequences of rigid motions. All right, head on over to the next page of the notes. I got a few more for us to try together. I'll meet you guys there.